Hi, in this video, I'm going to discuss the last state of SLJMCC 5 hard questions, right? Okay, let's get to the questions. Let me share the whiteboard. Right, so, so you see the top page of SLJMCC 5. So this was held on April 21st, 2024, right? So all the SLJMCC 0.5 and SLMICC 18 and 13, they have 24 short answer questions, and the scoring system is the same. So the easy questions, let me get my pen active. You get 5 points for each correct answer. And for medium questions, 6 points for each correct answer. And 8 points for each correct answer in the hard questions, right? So in SLMC, if questions were left unanswered in SLMC 8, 11, 13, the points were given. So, but here, there's no such thing, right? So let's look at the first problem, first question. So we look at number 17. The area enclosed by the square, the circle, the triangle, and the rectangle. Let me get my field color, light blue. Represent multiples of 2, 3, 4, and 9 respectively, right? And the question is, out of the numbers 2, 3, 4, 6, 8, 9, and 12, how many are inside the square, comma, inside the circle, comma, inside the rectangle, and outside the triangle? Now, one thing is that squares are rectangles, right? Now, here it says rectangle, so but I think there's no ambiguity here because this is the square, right? The rectangle must be this one, right? All right. So we need to figure out where these numbers are, right? Before I do that, let's say, where these numbers are, just for the, for the clarity of, our mind, right? So where is 2? So 2 is inside the square, right? But it is outside the circle, right? Circles represent, they're inside the circle represent multiples of 3. So 2 is actually outside the circle and also outside the triangle, which represents multiples of 4, right? So 2 is here. Now where is 3? So 3 actually outside the square, right? And also the triangle. So yeah, also the square, right? And also the rectangle also, right? There's 3 is here, right? Now where is 4? So 4 is inside the triangle, right? Outside the circle, right? Which represents multiples of 3. And of course, outside the rectangle. So 4 is here, right? Now where is 9? That is, of course, inside the rectangle, but it is outside the square, right? So 9 is here, right? Now let's see now these numbers, right? So we figured out, where these numbers are, 2, 3, 4, 9, right? So let's see now. Let's look at all the numbers out of these inside the square, right? Inside the square. So this inside the square, what are the numbers? So multiples of 2, right? 2, 4, 6, 8, 12, right? And so that's the first thing, right? What are the numbers inside the square? Now here the commas, right? So this actually n. The last one is n. So each of these commas actually is an end. Okay. So inside the circle, right? Inside the circle. So what are the numbers inside the circle? So multiples of 3, right? So 3, 6, and 9 and 12, right? Right, inside the circle. And inside the triangle, so triangle, inside the triangle, it represents multiples of 4. So multiples of 4, right? So 4, 8, and 12. And inside the, now actually we want outside the rectangle. Sorry, inside the square, inside the circle, inside the rectangle, and outside the triangle, of course. Right, we don't want this, right? So let's see inside the square, inside the circle, inside the rectangle, right? Right, inside the rectangle, which represents multiples of 9. It's only 9, right? It's only 9, right? So what are the numbers inside the square, right? Inside the circle, and inside the rectangle? Actually, you can see that there's nothing in common, right? Now 9 is there, inside the circle, but 9 is not inside the square, right? So inside the square and inside the circle and inside the rectangle, right? Nothing is there, right? So then if there's nothing there, then again, in there and outside the triangle, there's also nothing. So we don't even need to find out, what is outside the triangle, right? So what is the answer? No elements. It is 0, right? 0 elements. No elements, right? Okay. So we'll go to the next question. Questions 18 and 19. Okay. 46 chickens and rabbits, and their total number of legs is 146, right? If each chicken has 4 legs, yes. So it's like, suppose, can you imagine, chickens with 4 legs, right? Of course, in mathematics, we should have a big imagination, right? So this is nothing new for mathematicians and who actually do real math, right? Okay, it's like, suppose each chicken has 4 legs. Okay, then what is the increment? So this is what is, right? The increment in the total number of legs divided by 2. So this actually, the increment in the total number of legs divided by 2. So this comes together, right? Right? So if chickens has 4 legs, right, then the total number of legs is 46 times 4, right? And this is actually, so 40 times 4 is 160, plus 4 times 6 is 24. So this is 184, right? It's always easy to multiply like this, right? 4 times 40 plus 4 times 6, right? And this actually, what's the increment in the total number of legs? It is 184 minus 146. And this is, what is that? Is, 8, and then 7 minus 4 minus 7, take away 4 from 7. That is 3. So it is 38. Yes, right? And the increment in the total number of legs divided by 2. So 38 divided by 2 is 19, right? And what is this? Yeah, answer is 19, but then we know that this is actually, now these extra legs actually came from chickens, right? Because rabbits already have 4 legs. And then we attached, 2 legs to each chicken, right? And then we got this extra number of legs from those chicken. And then when we divided by 2, we counted the number of chicken, and that is 19. So 19 chickens actually, right? So that actually is not needed for this answer. So it is 19 chickens, right? All right. Number 19. If each rabbit has 2 legs, yes, removing 2 legs, right? Maybe each rabbit can actually stand on its 2 legs, and other 2 legs are like his hands, right? Arms. So then, what's the increment in the total number of legs? Decrement. Of course, then actually it has decreased, right? The total number of legs divided by 2. So this together, right? Right. So if rabbits stand, if each rabbit stands on 2 legs, then of course their total number of legs is 2 times 46, which is so 2 times 40 is 80, plus 6 times 2 is 12. So this is 92, right? And 92 divided by 2 is what? It is 46, right? So answer is 46, and this actually is the number of rabbits, because the number of legs decreased because rabbits stood up on their 2 legs, and then we did not count the other 2 legs. And then when we divide by 2, we got the number of rabbits, right? So 46. So the answer is 46, right? So 46 rabbits. Now we can check. So total number of legs, the actual number should be 146. So 2 times 19 plus 4 times 46, right? Should be 146. Let's check. So this is 38 plus we won't get this 146, right? Okay. 446 actually 92, right? Yeah, 92. So what is this? So this is actually so 8, 10. It is 130. I think there's a mistake somewhere. Let's see. 8. This is correct, right? So where is the mistake? Okay. I post and found the mistake. The mistake is actually okay, I'm going to use a red color, right? So we need to um, find the decrement, right? Which is what 146, right? Minus 92, which is it is 42. The decrement is 42, and that divided by 2 is 21, right? And the answer is actually not 46, 21, right? Good thing that I checked. And now we can check whether we get 146, the actual number of legs, right? So 2 times 19 plus 4 times 21, right? So we get 38 plus 84, right? And this is again not correct. Okay, let me check the mistake. Okay, I found the mistake. I'm terrible at arithmetic, right? So let me correct this. Let me get a new color, right? So I'm going to get a yellow color, right? So this is actually, what is that? This subtraction is not correct, right? It is, so it is, yeah, 54, right? 54. So 54 divided by 2 is, right? 54 divided by 2 is, what is that? 27, right? 27. So the answer here, it should be 27, right? 27. So we can check. 19 here. So 2 times 19, the actual number of legs, plus 4 times 27 should be 146. Let's check. So this is 38 plus this is 28. Okay, so 8 plus 2 is 10, 108. So 8 plus 8 is 6. And then it is 146. Now I got my numbers correct. Okay, now making mistakes actually it's okay, but you should not make mistakes in the competition. It'll cost you time, and also it'll cost you points, right? So, but when you do math, when you are learning, right, it's okay to mistakes, but you have to actually learn not to make these kind of silly mistakes, right? Okay, don't be like me. Uh, uh, don't do mistakes like me. Okay, all right. Let's go to the next question. So, uh, what happened? So, my board, right? So, right. So I'm going to shift this, right? Because no, I think I'll have to erase some of this stuff, right? Otherwise, we can't see. So let me get my eraser. So we need to do number, what is this? Number 20, right? Right, now we have some space here, right? Okay, let's look at this number 20. So the following sequence of A's and B's is obtained by adding letters in the following pattern. Right, so 1A, 2B's, 3A's, 4B's. Right, so we get the pattern, right? So next actually we have 5A's, 6B's, and so on, right? So how many successive A's are there immediately after the 55th letter? Successive means that, next to each other, right? So why can't I see my pen? The pen is troubling me. Earlier, actually, I made mistakes. Now, pen is troubling me. There's a call here. So I will not answer that call. Right. So for instance, there I have a pen, right? So I need to, what happens? Okay. So how many successive A's? That means block of A's, right? Are they immediately after the 55th letter? Right. So 1A, 2B. So 1A, there are 2 Bs and 3 A's again, right? So we need to find out these numbers, right? These sums. So after this many, right? So here it is A, so B, so this block of 2, right? And here A, and here B, right? So after actually 1 plus 2 plus 3 plus 4, which is actually 10, then you get 5 A's, right? 5 A's, right? 5 A's. And then, so that is actually now, it is 15. So after 15, so we need to get to 55. 55. Now, 55 is a familiar number to me. I don't know about you, right? I know that 55 is actually the sum of the numbers from 1 to 10, because those numbers, occur frequently, and then I added them up, right? And I know that they add up to 55, right? So let's see, right? So I add them up, 1 and 10. Yeah, first I pair them up, right? And then 2 and 9, right? So each pair adds up to 11, and then there are 5 such pairs. So this is 55, right? So then what is the block of 10 here? Block of 10. So the even blocks are actually B's, right? It's a block of 2 B's, right? So this is actually a block of 10 B's, right? And up to 10, right? We have 55 letters, and after the 55th letter, a block of 11 A's, right? So how many successive A's? It's 11. It's 11 A's, right? Hope you got it, right? If you didn't get it, think about it and come back and watch this part of the video again. As I say always, before you watch me solving the problem, right, you need to stop the video and do the problem, right? All right. Let's go to the next question. For questions 21 and 22, we have one setting. Umare has 9 rupees 1 and rupees 2 coins. When a 9 coin values are written in each of 1 by 1 square, that means small squares of 3 by 3 square. We have this 3 by 3 square. The sum of numbers in the following shaded 2 by 2 squares, right? Yeah, are all equal to 6. Right. So, we get a good color. I'll get, let's see, right. So, in the red block, right, the number should add up to 6. So there are 4 squares, right? So numbers are, point values are either 1 or 2. If all of them are 1, then it's the sum is 4. And if one of them is 2, it is 5. Then we need to have 2 of them 2, and the other ones are 1 each. That's how you get 6. If you know 3 of them are 2, then of course it's more than 6. So each block has 2 2s, and others are 1. Right? So then how can you have 2 2s in each one of these shaded blocks? Right? So you can think. So we can think in many ways, right? We can think visually, we can try things, right? So I'm going to try something like this. So if I have these 2, right, like this, 2 here, 2 here, 2 here, 2 here, right? Then you can see that, each block, right, has 2 2s. If you make the other ones 1, right? Right? You can see that, then each block actually sums up to 6, right? So I actually sort of a pattern, right? So here, so what's the question? What is the maximum amount of money she can have? So if this is the case, right, then she has how much money? So 2 times 4, which is 8 plus 5, so 13 rupees, right? 13 rupees, right? This is the only way. Well, how about like this? So if I like this, right? So the red one, yeah, red box has 2 twos. Green one, of course, has 2 twos. And what about the yellow one? That also has 2 twos. And green, yes. So if you have like this, right, then all these 4 blocks have their numbers are add up to 6. So what is the amount of money here? Rupees, how much? 2. So this is 2 is 3, 6 plus 6. So 12 rupees, right? Is it the only way? Right? So how about like this? We put it 2 in the middle and 2 at the corners and 1 in the other small squares. Red one, 2 twos, green, blue, 2 twos. Yep, this works. So what is the amount of money? The rupees. So there are now 5 twos, which is 10 plus 4 ones, 14, right? So the amount of money went up, right? But is there another way, I mean, are these the only ways? Now, this is a bit hard question, right? Yeah. So, of course, we should like, solving hard questions, tough questions, right? That's how we learn, right? If everything is easy, then there's no thrill, right? I mean, if everything can be solved very easily, there's nothing, no enjoyment, right? So enjoyment comes from, solving hard questions, tough questions, right? So I can see another way, right? How about like this? So let's first check red, fine, 2 twos, right? And green, 2 twos, blue, of course, 2 twos, and yellow, 2 twos. Yeah, this also satisfies the given conditions. So how many twos? 6. So 2 times 6 is 12 plus 3, 3 ones. So this is 15. So this one would be 15. So is that the maximum, right? Is there another way, right? Well, I leave it to you, right, to find out whether there are other ways of uh, arranging, these ones and twos so that each shaded block has only 2 twos, right? And they add up to the numbers in the shaded blocks add up to 6. So I give my answer. It is rupees 15 is the answer. That's the maximum, right? And how many different total numbers of money she can have? She can have 4 different numbers, right? The answer is 4, right? All right. So hope you like that question, those 2 questions, right? All right. Let's look at the next yeah, 23 and 24, and they are based on a magic square, right? 3 by 3 magic square, and here these letters represent whole numbers, including 0, and the numbers in each column, row, and that adds up to the same number. How, right? And we are given A, D, and E. A, D, and E. We find the sum of B, C, and H. Now, how do we find, if we knew the magic sum means that what, these rows and columns and the diagonals add up to. If we know the magic sum, then we can find out this very easily. So we can find I first, and then we can find F. After finding F, we can find C, and then B, till we can find all 9 numbers, no problem. But the problem is that the magic sum is not given. So that's a problem. So that's why this is a bit challenging, right? So you should try something, right? Now, here you will not see the answer immediately, right? Like, lots of questions at school, right? It's like a chess game. You need to get the answer in a few steps, right? And by doing this kind of problems, you get that skill of, going a few steps and solving the problem, right? So since I want to find out the sum of B, C, and H, right? So one is that actually I can add the numbers in these 2 columns. And if you ask why you do that, you have to wait till, right, I make the next move, right? So B plus E plus H plus Z, right? Plus C plus F plus I, right? So now here I have BCH, what I want. So where is B? B is here. It's like D. So let me write them together. B plus C plus H. And is of course given, right? What is that? It is actually 6 plus F plus I, right? If I know F plus I, we can find, right? B plus C plus H, but we don't know. So I'm doing some visual thinking, and I'm going to get a different color, right? So since F is there and DE I know, I'm going to look at this row, and then there's I in this diagonal, and AE I know. So if I add them up, it has to be equal to this, because 2 rows add up the same, and this row and the column, they add up to the same number, because each row, each column, each diagonal adds up the same number, right? All right. So A plus E plus I, that diagonal, right? Plus that row, or D plus E plus F. So A is given, which is 5, and E is given, which is 6. And then I'm going to keep, there's an I, right? So remember, okay? And there's a D here. So D is actually 4, and E is 6, right? And then there's F plus I, right? So what do we get? wait a minute. No, this is not actually equal, right? It's actually plus. See, I make these kind of mistakes, typos, right? So this plus, right? So this is what we want to find out, right? Now, when you have something like this, an equation, right? So it's like a balance, right? You have two pens, and on the left pen you have this b plus c plus h and 6 plus a plus I. On the other pen you have 5 plus this one. So we can actually add or remove the same weight, same things. So you can see that if plus I is there, this is like two these are weights, right? So we can remove them. You remove them, right? Of course, numbers, we don't what about numbers, right? So that means, right, B plus C plus H, right, is B. And we can also remove 6, right? That weight we can remove from the two pens, right? And then what do we have left? So we have left 5 plus 4 plus 6. So we remove this, right? So what is this? It's actually 15. So the answer is 15, right? Yeah, that's a bit challenging, right? So if you didn't get it, well, you need to stop the video, take a walk, do something, and come back, or work it out and come back. All right. Number 24. If a plus g is 11 and a plus, then find e plus f. Right. Now what I'm going to do is that I'm going to erase these, right? Then actually we can see what's going on, right? So we want e plus f, and we are given a plus g. A and g are given, right? So now you think visually, right? And you can see that this row and this column and these common. And the sum of the numbers in this column and that row are the same. So let me get a different color, like blue. So a plus d plus g is equal to d plus e plus f, right? So d is common, that weight we can remove from two pens. So we remove this d from the two pens, right? And a plus g is given, it is 11. So 11 is equal to e plus f. And that's, so the answer is 11. And of course, 24 is easier than 23, right? So this should have been 23, right? And 23 should have been 24. Right? Anyway, hope you like the two questions, right? And there's a message here. Hey there. So pause this one and read. This is also a cartoon, right? Okay. Before I wind this up, this video, right? I want to go back to the question I did in the previous video, right? This question of, these figures, right? We need to find here how many figures have parallel lines, an interior right angle, and less than 6 sides, right? So you need to watch that video, right? So some of the things, I forgot when I was doing that problem. And then actually what I did, because I could not remember how you indicate parallel lines, right? I later remembered, but then by that time, I had actually used a way which is not used. Right? So you actually indicate parallel lines by drawing feathers on them, right? So here, the line said, so this line on which I put a feather, and feather, so those two lines are parallel, right? That's how we indicate. Now, if you have more than two pairs of parallel lines, for example, here, so these two are parallel, and then here I draw two feathers. So these are also parallel. That's the correct way, right? And then, yes. So, so number 12, right? Let's indicate all the figures with pair of parallel lines, right? Figure A doesn't have. So figure C has, right? Here, one pair of parallel lines. D doesn't have, and here one pair of parallel lines. And here F, one pair of parallel lines, right? So H, one pair of parallel lines, and I, one pair of parallel lines. So they all have a pair of parallel lines. An interior right angle. Right angles are shown like this. So there's a right angle there, interior. This is also right angle. So no right angles here. So there's a right angle. And here is a right angle. No right angle in H. Here there's a right angle. Right? So let's now circle, parallel lines, right, and right angle. So B, C, F, G, I. So now we have, so these five are there. And out of those, how many have the last condition less than 6 sides? So this has 4, right? So I'm going to use a different color. So this has 4. So this is one figure. This has 12, and that is called a dodecagon, right? That also I forgot. Dodecagon, and it has 12 sides. And then F has how many? It's a pentagon side. So that was actually, we need to count. And number 6, so it is also pentagon. We have to count. And I, of course, is a hexagon, right? 6 sides. We can't count. So here the answer is B, F, G. And this is the answer. Answer is 3. There are 3 figures with at least one pair of parallel lines, at least one interior angle, and less than 6 sides. Okay? Right. So let's do number 13. So I'm going to erase this, right? Because you need to, what do you call, keep, what you are doing, bookkeeping, right? Otherwise, you can make a mistake. So in number 13, not regular. So, so EN is a regular pentagon, and so A is a regular pentagon, and A is a regular hexagon. All the others are not regular. Regular means that the interior angles are the same, and so equiangular. That means equiangular. So these terms you need to learn because you will not be in equiangular in grade 5 or right forever. So you'll be going into high grades. So you'll be learning these terms, right? Equiangular. And then each side has the same length. So equilateral. Right? So A and E, we need to strike them out, right? So we don't worry about them. So all the others are not regular, have an acute angle. That means an angle between 0 and 90, right? Less than a right angle. Okay. So let's indicate if a figure has an acute angle. So this is acute, right? And C doesn't have acute angles. And this is acute. And this does not have acute angle, right? This doesn't have, so we need to, okay, this we need to discard, right? This we discard. This is bookkeeping, right? Discard, right? Discard. Now here, this has an acute angle, and here an acute angle. So how many are left? So left. So let's circle them, right? This is a thing, that you can easily make mistake, right? So here we need to check for the last condition, right? Here we need to check the last condition, right? And here we need to check the last condition, and here we need to check the last condition. What is the last condition? Obtuse angle, one between 90 and 180. Bigger than right angle and less than straight angle. Right, obtuse. Let's check. Let's use a different color, otherwise, I'm going to make a mistake. Range, right? So B has an obtuse angle. This is between 90 and 180. Now, these so I'm going to use the red color, right? So these actually is an acute, right? And then this one, right? This one is actually bigger than 180. It's a reflex angle, right? So we can't count. So we need to strike it out, right? So we need to strike this out, right? What about H? Does it have an obtuse angle? Here, this is obtuse. And what about I? Yeah, this is obtuse. So the answer is actually B, H, and I. But that's not the answer. Answer is actually 3. So there are 3 figures. With not regular has at least an acute angle, one acute angle, and has at least one obtuse angle. Yeah. So there you are. We did that again. So that's the end of this video. I hope you liked it. So until I meet you again in another video, right? Take care.